In this video, we're going to take a look at a specific case of one sample data. Now, in this case, what we're going to do is we're going to have one sample of people, but we're going to collect data from them twice. So rather than two samples like we had in the last section, it's really only one sample. And you do these a lot of times in maybe before and after type things, or maybe comparing two things. So maybe you're testing a new blood pressure medicine and you have the patient use the new medicine for a month, and then you record their blood pressure at the end of that month. And then you also have that same person a few months later use the old medicine and measure their blood pressure at the end of that month, and then you compare how much better or worse maybe their blood pressure is between the two medications. So that's kind of where we're looking at. We're looking at the same person twice, getting two different treatments. So what's nice about that is it eliminates a lot of the extra confounding variables, because you can't get any more alike than comparing yourself to yourself. So this is called paired T procedures, but it's really just a special case of a one sample t-test. So there's no new formulas. You use the old calculator commands that you did in your TI, like we did at the beginning of this unit. So nothing new here. So here's an example. So here we want to look at how people react to having caffeine taken away from them. So we're looking at two separate days, and we're looking at giving them a caffeine and a placebo. And then we also want to be careful that we're going to randomly assign each person whether they get the caffeine on the first day or whether they get the placebo on the first day. So maybe you're going to take each person and flip a coin or something like that. So that way you get some people getting the caffeine the first day and other people getting the caffeine the second day. And then we want to know, how does that relate to depression? So here's our 11 people. Some of them got the caffeine first, some of them got the placebo first, and then for all of them, we're recording the information the same way, and we're looking at the difference of placebo minus caffeine for their depression scores. Now, it's important for us to randomly assign the order because we don't want there to be other confounding variables that impact that. So maybe something unusual happens on day 2 and everyone's a little different on day 2 than they were on day 1. Like maybe they didn't get enough sleep the night before because there was a thunderstorm or something like that. So by maybe flipping a coin and having some people get the placebo first and some people getting the caffeine first, that's going to help with that. Now, as we prepare to do a test or a confidence interval here, remember that it's the same thing as the one sample T procedures. So basically in that table we were looking at a few moments ago, we're ignoring the two separate scores and we're just looking at the last column where we had the difference in their depression scores. So we still do the whole state, plan, do, conclude procedure. So we have our hypotheses where we're going to say, okay, we think that the difference between these two treatments is non-existent, it's 0. Or we think that the score for their depression will decrease, which means the placebo minus the caffeine would be a positive number. So you start with your state step where you are giving your hypotheses. Notice we do change the notation here a little bit. We use a mu sub d, and the d stands for difference. Make sure in your state step you define whether you're doing placebo minus caffeine or caffeine minus placebo, similar to what we did when we had 2 groups and we defined it that way. And remember, we can pick any alpha we want, but 5% is the most common. So then our plan step, so we're doing a one sample T procedure and we have to check our conditions. So it says here that we were randomly assigning them to the 2 treatments and we randomly assigned who got which treatment first. Because we're not sampling and we're doing an experiment, we don't need to check the 10% condition, but we do want to check our normal condition. So we were not given information that the population of depression scores was normal, so we don't have that. Our sample sizes are not big enough to meet the central limit theorem, so we don't have that, which means we need to look at some sort of a graph. So maybe a dot plot, a histogram, a box plot, a normal probability plot. Whatever we can do, we're going to take those 11 scores and plot them out. And what we're looking for is that we're looking for no strong skew and no outliers. So we don't see any of that in these data displays, so it should be safe to proceed on to our do step. So remember, your do step would be to write out the specific formula, the general formula, and then either plug in the numbers or use your calculator to get your test statistic, and then either use table B on your formula packet, or use TCDF, or use your one sample t-test in your calculator. Any of those things would work, and you're going to get your p-value. Now, your conclusion is going to be the same, like fill in the blank sentence as you've used all throughout the previous units. So assuming that there is no difference between the placebo and the caffeine, then there's a 0.0027 chance of getting results like this or more drastic purely by chance. Because that p-value is smaller than 0.05, we do reject our null hypothesis, and we have convincing evidence that the depression scores get better when people are taking the caffeine rather than the placebo. Now again, there are no new calculator videos. You're just using the calculator the way you did in Chapter 8, Section 8.3, where you were using the confidence intervals and the significance tests for one sample t's. Same thing here, except for you're basically, again, ignoring those first couple columns. Let's go back to our data table here, where we were ignoring these first columns, and essentially all that really gets put into your calculator are the difference numbers. So go ahead and try the practice problems before moving on.